Hello everyone and welcome to this new tutorial of Plaxis. So are you new to Plaxis or are you a beginner? Or also do you know how to use the software but want to go deeper in every and each command? Do you have a project for university or do you have a project for work? If yes, this is the right tutorial for you. In this video I will be teaching you everything about Plaxis. After watching this video you will know how to use Plaxis interface, and also how to do a exercise in it. And then there will be a lots of other videos on my YouTube channel that you can also watch. So in this tutorial I will start by Plexus 2D and then finish also in Plexus 3D. So in the end of this video you will be a pro in Plexus. Before I start, if you're new to this channel and you love learning, subscribe to my YouTube channel, it will be very helpful for you. So first of all, what is Plexus? Plaxis is a plane strain and axial symmetry software. This is why it's called the Plaxis. It's a finite element analysis. It performs finite element analysis in the geotechnical field. It includes deformation, stability, and water flow. It's for the Bentley, the Bentley organization. So where did Plaxis come from? Plaxis was originally made in 1987 in the Dutch by the Dutch ministry. It was made in the beginning only for embankments and to calculate the embankments. It was made initially in 2D. It was a 2D software, and then it was upgraded to a 3D software and upgraded to be used in the geotechnical field. So first of all, after entering Plexus, you will obtain this format. So here there's a start a new project and open an existing one. So these are recent projects. You can start a new project or you can choose a file that you have saved anywhere on your laptop or PC. So here we're gonna start a new project. After pressing on start, you will get the project properties. So this is Plexus 2D. You can see here that it's Plexus 2D. You can name whatever you want, the title, the company, directory, file name, if you have any comment, and also the company logo. Here, this is the model. It's a plane strain or axisymmetrical. For axisymmetrical, it is used to draw circular objects. So you only draw a, uh, a radius of the object and you press on axisymmetrical. It will model it as a full circular object. Here is plane strain. Usually we will use plane strain. Only for circular footings we will use axisymmetrical or circular structure. Here are the units. You can find meter, millimeter, centimeter, forces, time. So here for the time, it's crucial to know what to choose. Usually in dynamic analysis, we're talking in second. In consolidation in days. So it depends on the calculation you're about to choose. So here is the temperature. It's Kelvin, Fahrenheit or Celsius. This is the energy, power, and these are the stress and weight. So here it's the contour of our project. So this is X maximum and this is X minimum in this direction. And this is Y maximum and this is Y minimum in this direction. And here are some constants that are used in Plaxis. There's the gravity, which is equal to 1 in minus y direction. There's the Tref, the temperature, which is put here. The earth gravity, the water, gamma of water, the liquids, water, and everything you can find here. Ice, vapor. So we usually do not change these constants. We usually leave them as they are. But if you have a special exercise, you can change them. So I will leave these, or I will put here -8 and generate a soil. So this is -8 and +8. So here it's divided in two. There's the blue and the green part. The blue part is everything about designing. You draw your structure, you draw your soil, and in the green you create a mesh, you do flow conditions, and you uh, calculate the final file. So here in the soil, there's the select option. There's a select multiple objects, select boreholes or generated soil. Here it's the move borehole. Here we create a borehole, and here we import a soil, and here we show the material. These options are also available here. So usually we start by creating a borehole. We can press anywhere we want, and you obtain this format. So what is a borehole? A borehole is a type of drilling. We drill in the soil to see what the soil is formed of. So here in this software, you define the material in the borehole. So you tell the software that I've created a borehole in the soil, and I obtained that for 0 to -10, there's a particular soil here. So we have to assign a soil. There's no soil created, as you can see. Here we will create a soil. So these are the soil parameters. Here is the identification. I'm gonna put soil. Here is the material model. There's all these material models that I've previously talked about in a tutorial. You can find that tutorial in my YouTube channel for the material model. Here there's also the drainage type, which I've also talked about. It's undrained, BC, or non-porous. Non-porous is like for concrete. Here you can find the definition for undrained. Like for A, it's short-term materials in which stiffness and strength are defined. You can read them or watch my other video on the YouTube channel. So here you can put the gamma. I'll put it here 20. The gamma set should be higher or equaler in value for the gamma unset. Here are the void ratios. Here are the parameters. I'm gonna choose a 2000 stiffness. Here I obtain all the values by default. Here is the friction angle, which I put the 10. The phi angle, which I put the 4. And I've also made the separate tutorials about each and every parameter in the material. Here we define the groundwater. There's models for the water, the thermal condition, the interface, and the initial. So for the interface, for each and every structure that you will draw in the soil, the structure, especially if it's made from concrete, it will be much stiffer than the soil. So this is why we should create a interface which will model in real life the where the structure will touch the soil. There will be a small failure in the lining on the shield of the structure, and here it will be drawn as a interface. I'll press OK for creating the material. Here I can also edit the material. I can go to material, press and edit. For now I'll not edit it. Here there's the water condition. We leave it to head, which means that it will start from 0 and go down. There's many options: hydrostatic, interpolate, dry, and user defined. These are the initial condition, pre-consolidation, and field data. You can import a file from the real data collected on the soil. Okay, for now we'll only use these. Here in the materials, which you can also access from here, there's soil and interface, plates, geogrids, embedded beams, and anchors. The piles will be drawn here in this area, embedded beams. So here there's also a soil test. You can perform a soil test in Plaxis. You can find also a tutorial about this on my channel. So basically everything I'm gonna talk about, there will be a tutorial which I'll go in details about it. You can check them on my YouTube channel. Here I will go about the basic in order for you to know all the Plaxis interface. Okay, so I'll get out of it now. Okay, I'm back in the model. This is the soil that I've created. So let's go to structure. By the way, we could have created different boreholes here to create a soil slope. So for example, if I created a borehole here that started on +1, the slope would have been like this. Here, this is the structure. Also, you can find here the properties here. By the way, if you go to uh, let's go to structure option and display. Okay, I'll show you this option in the 3D tutorial. So here you can select multiple objects. You can select soil, structure, points, or even lines. Now we'll see these later on. Here it's the move object. Here it's the array. We can create multiple objects by copying it. Here these are create points. So there's four types of points. There's a simple point, a point load, point displacement, and create a fix and anchor, which will connect, for example, a embedded beam to a anchor. This is the line. There's a line load, line displacement, line contraction. So for the line contraction, it's a contraction in the soil. For example, after drilling a tunnel, there will be a small contraction on the lining of the tunnel. This is create a plate, geogrid, embedded beam, create an interface, end-to-end anchor, well, and create drain. So the difference between a well and a drain, a well you can remove or add water in just one point. But for the drain, it's a line. You can remove water from a line or add water in a line. This is the ground flow boundaries, and this is the thermal boundaries. So for the boundary, you can choose that it's closed. For example, if there's a flow of water from here to here, we can choose here that it's closed, and here it's open. Now we can create the soil here, create soil polygon, create soil rectangle, follow contour, cut. For example, we can create a soil here. This is the soil that I created. I can left click on it, soil, set material, and choose the soil material. Or I can create a new material also. So here we can create a tunnel. Here we can create a point load and a line load. Here the displacement, contraction, line displacement, and point displacement. Here we can create structure, fixed and anchor, create plate, geogrid, embedded beam, interface. We've also seen them here. Here the water condition, the thermal condition, the connection, which will be between plates and embedded beams, for example. Here we will create an interface on the boundaries, like here. And here we can import a geometry, and this is the material option. So we can also change, for example, let's draw a plate. I'll show you how you can change the material here. I will draw a plate here. So this is the plate. I will also draw a line load on it. So I press on this plate. I can go to plate and press on it. Okay, I will delete the load just to show you something. And I'll redraw a plate from here to here. I will left click on the plate. So there's no material here. I will go to material and go to plates and create a new material, which I'll name plate. And I will choose any value here. So now I can assign this plate, the material that I created, to the plate. And I can now put a line load on the plate. For the line load, I will put that is equal to -1. I leave it this way, -1 kilonewton per meter. So here we've seen where we can draw in the structure. you can do multiple stuff. So for example, I will create a embedded beam. For example, an embedded beam would be a pile. So I'll put a pile here. This will be our pile. I will go to material, plates, embedded beam, and I will add a new one and I will name it pile. I'll put any values here. Diameter, it's 1. I press on OK. I'll go to right click, embedded beam, set material, pile. Here you can see the option of the pile. Apply strength reduction, pile, behavior. It could be a pile, a rock bolt, or a grouty body. Connection point, top. Connection rigid. It could be hinged or free. This is the free. This is the hinged, and this is the rigid. I leave it hinged in this tutorial. The material color. Also, you can see now the plate here. Apply strength reduction. You can see the line load. You can change from the line load. Here it's the dynamic multiplier. You can add a dynamic multiplier, which would be a dynamic force. Let's say it's a harmonic force. I'll choose an amplitude of 1. Phase frequency would be 3. And I will create a signal. Here we can also add a signal from an Excel sheet or displacement multiplier. For now, I will add nothing here. Okay, I leave it as it is. So we can also create a tunnel. I press here, I'll choose the shape, circular or free. I leave it circular, the whole tunnel, half tunnel, left half. And also I can choose the axis to begin from, the segments, and the subsections. I will not generate one. So we can also define a prescribed displacement and assign we can also assign a groundwater flow boundary, which is this one. For now, I will not use these parts. So now after drawing everything, we go to mesh. So here it's the select, it's the check geometry, refine the mesh, we can refine it or coarsen it. Here we can reset local coarseness, and here we can generate a mesh. Element distribution medium, you can change it from very coarse to very fine. And there's also expert options, which I will leave for now. I will press on OK. Now it's generating our mesh. We can go here and see it. So now after pressing on this button, we can see the mesh that was generated in our soil. This is the mesh, this is the force, this is the pile. So this is our mesh. So after finishing the mesh, we will close it and we'll go to flow condition. So here we'll choose the water level. We can draw a water level, for example, from here to here. Press on enter, and I will say make global. This will be the global water level. For now, I'll leave it this way. You can choose a water boundary. Say that this is here a closed water boundary. You can also choose import a water level. So this is it for the water condition. Now we'll go to the stage construction. So what differs Plaxis to other software is that you can define phases. For example, this is the initial phase. There's nothing that turned on, only the soil. So for the first phase, there's two types of calculation. There's the K0 procedure and the gravity load. So the K0 procedure is the direct generation of initial effective stress, pore pressure as state parameter, equilibrium not guaranteed. Gravity load to be used for no horizontal layers. So for here, I will use a gravity loading. because there's this soil here. But for the initial phase, I will be generating this soil here. I will be adding it. If I didn't add it, I could have used K0, but because of the slope here, I will choose gravity loading. Here, it's the stage construction, phreatic level, time interval. Since there's no consolidation calculation here, or dynamic, we will not use the time here. For all the parameters, I will not show them in this video. Then I will add a phase. This is the phase 1. I will name it pile, plate, and loading. I will press on OK. In this phase, I will activate the line load, the interface, the embedded beam, the pile, and the plate. I will go to this calculation. I will choose plastic. There's consolidation, safety, dynamic, fully coupled flow deformation, dynamic with consolidation, and I will leave all these values here, and I will press on OK. So here there's this button that I have not talked about. It's select a point for curve. So this button here will select a point to see the deformation after the calculation. So I will choose this one here since it's on the top of the pile. I will update it. I will go to stage construction and I will launch the calculation. But before I do, I want to show you something else in the interface here. So here we can activate or deactivate the soil. For example, we can activate it and deactivate it. I've deactivated it and activated it. Here we will select. So this here shows us that we didn't calculate the initial phase. I relaunch the calculation. This will take a little bit of time. You can see the CPU and the calculation that's done on this table here. So this calculation usually takes a little bit of while. It depends on your PC, and we usually can obtain errors. So for the errors, I've made an entire playlist that contains most of the error that you can encounter in Plaxis and how to solve them. You can find also this playlist on my channel. So here we can see the calculation in progress. This is the graph, the M stage, and the information. So the calculations are finished. We can go here to see the calculations. After we go and see the output, here's the initial phase and here's the phase 2. So we can see the initial phase. You can go to deformation and total displacement. We can see the total displacement here. Of course, the displacement here are not correct since I've put any values in the soil. We'll go to phase 2. Here we can see the displacement. So the displacement here went to blue because there's a large displacement on the top of the pile. We can see also the stress that's created on the soil, the effective stress. You can see it here. This is the stress. We can see the groundwater head. Here there's no head since the water flow is like this. We'll see the water head in a other tutorial. These are the plastic points of failure. There's no failure points. I will choose failure and tension cutoff. These are the tension cutoff here on top of the pile. So now we can create also a curve manager. So we can create a curve from the point that we've chosen on the mesh. I'll choose here node, deformation. I'll choose total displacement, and here I will choose for the steps this one. We can see the deformation when it comes to the stage of the calculation here. We can save it or unsave it. So that's for the drawing of the plexus in 2D. Now I'll see the 3D. I will do a very fast demonstration here. I will add a soil. I will name it tutorial 2 and 3. Choose here anything just to not get a error. I will make a borehole. I will choose -6, any value, press OK. So as you can see here, it's the same interface. Here also, there's some interfaces that are the same, but there's new buttons. I will check them with you. So here there's the visualization settings where you can set the visibility of the objects and also the grid and the snapping. I will leave them as for default. Here are the snapping and the grids. Okay. So here the selection is almost the same for the 2D, but there's also new stuff like the 3D object and the soil. Here it's the move. Here it's the extrude. So we can draw, for example, a surface. I'll draw any surface here. Okay. And I can extrude it. Let's say it's -1. We've created our surface here. We can also create surface by changing the points here. So I will not create the surface, I'll delete it. We can choose array, where we can array the surface or the line. Here are the points. They are the same as for the 2D tutorial. Here we can create a NURBS curve, embedded beam, line load, line displacement, node to node. This is also an embedded beam. So here it's a simple beam, and this is the embedded beam. It's a simple beam that can be used for like a simple beam and not an embedded one. There will be no friction on the surface of the beam. This is the well, drain, and movement. We can add a movement. This is the plate, the surface. We can add a surface. Here there's no plate. This is the polycurve. We can draw a circle or any curve that we want. And this is the tunnel. We can create a tunnel. The load, for sure there's a surface load, not like the 2D software. Here there's displacement. Here we can create structure. Interface, there's a negative, a positive. The negative and positive interface do not mean anything. An interface is an interface. It's just to annotate them. Here it's a geogrid. We can create a geogrid with it. This is the plate, embedded beam. As you can see here, we create surface and here a plate. These are for the structure. Here it's everything concerning the water. As you can see, there will be a groundwater flow surface boundary where we can draw a surface on the entire model. And here we can add or remove materials. These are the same as for the 2D software: plates, geogrids, beams, embedded beams, and anchors. So I press on OK. So for the interface, it's almost the same. Here it differs in the structure. Well, you should know something important when it comes to 2D and 3D. It's always better to draw on 2D when you can, because it's easier and faster. When the geometry becomes more complex and complicated, it's better to draw it in 3D, since there's no other option. But whenever you can draw it in 2D and save some times, you can do it. And also for 3D, you should know how to draw. This is why it differs on how you draw it in 2D and 3D. In 2D, we're talking about points and surfaces. In 3D, we're talking about volumes. And also what you should know about the 3D is that we should draw every time in the purpose of saving some time and energy in drawing. So for example, if you have this volume which will represent a tank, we can draw only the quarter of the tank. Like for example here, This will be the quarter of the tank to save some time and the computer calculating time. This will be easier and faster, of course. So here you can see the view, top, right, left, bottom, up. I'll leave it here. You can rotate, of course. Here I press on the object and rotate. It will rotate. You can see the objects. Here there's undo and redo, save, open project, new project. And here for the expert option, I'll talk about it later. Now, should not worry about this. In the mesh creation, it's the same interface and the same button. So I create a medium, or I'll create a very fine mesh. I press on OK. It's creating the mesh. So it might take a little bit of time. It depends on your PC. So I leave this flow condition, and here's the stage construction. So it's the same. So now I'll upload a exercise that I've already made on Plaxis for it to see the results, and I can explain the results deeper in details. So this is an example that I've already uploaded on YouTube. We can see here the structure. This is the polygon, which is here set to seepage. These are the boundaries of the drawing. So this is an embankment. Here it's different material from the core of the embankment. We can see here the materials. There's the core, which will be a material that will not transmit water through it. Here it's the fill, and here is the subsoil. I press on OK. We can see also that the ground boundaries come from down to up. Here is the stratigraphy, the geometry, the surface boundaries, the volumes. So here we can see the mesh. This is a mesh that we've also already created. This is the mesh of the object. Let's see the stage construction. So we can see here that this is the high reservoir. This is the initial phase. The gravity loading, since it has a slope, and steady groundwater flow. This is the first analysis, which is a rapid drawdown. So this is a little bit complicated. This tutorial is a little bit complicated, but I will not be explaining it since it's already uploaded. But I will also only explain how we can see the results and how we can take the results from Plaxis. So here you can choose the table for you to take all the results and put them in the table. This will be the cluster and the table, the formation and number of the nodes. So for example, if you go to principal stress, you can see the stress on each and every soil, each and every stress point. Of course, you can take them to Excel. Here, as usual, we can draw the curve. I can choose a node, choose the formation, total displacement, and here I can choose, I will choose this one, the safety factor. Okay, so this is the chart that I've obtained. For now, I close this one. I'll not save it. I'll go back to the output. So here I can do a slice of the project. So this point here is minus 130 and 20. So I'll choose in the X direction 0, and in the Y direction also 0. Now in the X I'll choose 1, and I will leave it 0 in the Y. So there's now a surface that will pass by the middle of the dam. So there's an error that it does not intersect any soil. I'll choose it, this value. So now we can see the intersection. For example, these here are the displacement, total displacement of the soil. We can go to groundwater flow and we can see the flow through the embankment. We can see it through the phases here. This is the high reservoir here. You can see it also in arrows. And I want to show you also the groundwater head. These are the groundwater heads. So this is it for this tutorial. If you have any question, just leave them in the comment section. And stay tuned to my YouTube channel for more videos about Plaxis. Thanks for watching.